Hey there, this is Matt Gorman. Let's talk about gears. There's a lot of great information on the internet that tells us about gear ratios, but it's all very technical. I'd like to take us a little deeper and back up and really understand what's going on, what goes into a gear ratio, and how does it really impact the way we propel a bicycle forward with each pedal turn. So let's begin by taking a look here at what is called the high wheel bicycle. This is the old-fashioned bicycle from many years ago that we would have no gears on this bicycle. It would be a large wheel with a rider would sit up top, and here are the handlebars. These wheels had a diameter of about 52 inches. Multiplied by pi gives us a circumference of 13.6 feet. And that meant, because these pedals are fixed to the wheel, one pedal turn would turn this wheel once, and thus moving the bicycle forward 13.6 feet. At a cadence or revolutions per minute, pedal turn of about 60 turns per minute of the pedal moves this bike forward about 9.3 miles an hour. A more vigorous pedal turn or a cadence of 90 RPM would give us a speed of about 14 miles an hour. So let's go over here now. How does that contrast with a road bicycle wheel that I've drawn here that has a diameter of only 27 inches? Multiplied again by pi gives us a circumference of 7.2 feet, which means in the absence of gears, pedals fixed to this wheel, one pedal turn only moves this wheel and thus the bicycle 7.2 feet. At a cadence of about 60 RPMs, this bicycle is moving at only about 5 miles an hour. More vigorously, cadence of 90 RPM, we're moving the bike forward at 7.5 miles an hour. And at race pace, say 25 miles an hour, would require a pedal speed, revolutions per minute, of over 300, which is humanly impossible. So I'd like us to look at some gears on a bike, do a little math, and see what's going on. In the front here, we have what's called the chain ring. This is a standard two-ring system where it's a 53, big ring, and the small rings are 39. There are other configurations. But in the back here we have what's called the cassette, and anywhere between 9 and 10 cogs or sprockets that can range as low as 11 tooth in the little one up front, and the big one in the back up to as high as maybe 28. I have this bike in the configuration of in the 53 tooth in the front, the 15 in the back. 53 divided by the 15 gives us the gear ratio of 3.53. What does that tell us? So I'm going to turn the crank arm one time and see how many times this wheel turns. I have the crank arm in the 12 o'clock position, and we're going to count our valve stem right here, how many times that comes around. So I'm going to start to turn the crank arm, and we'll see now that the valve stem is now coming back up to the top for one turn. I'm going to continue to move the pedal cranks, and we see the valve stem now come up for the second rotation of the wheel, and continuing to turn the pedal cranks, we now see the valve stem come up for its third turn of the wheel. And now by the time we bring the crank arm back up to the 12 o'clock position where we began, one full turn of the pedal, turn the wheel 3.5 times. That's our gear ratio, 3.53. So one pedal turn turns this wheel 3.53 times in this gear configuration. Remember our multiplication where A times B equals B times A? What's happening is with the 53 tooth up front, we turn that 15 times, it'll equal the same as turning the 15 tooth 53 times. Again, so then we take the 15 and divide it by 15 to get one turn will equal the 53 divided by 15, which, as we just said, is 3.53. So that is how one turn mathematically equates to 3.53 in this particular gear configuration. Now, of course, if we move this into different chain rings in the front or different cogs in the back, that'll give us a different gear ratio. But what does this gear ratio do for us on a 27-inch wheel? Well, if we take this 27-inch wheel, let's look over here for a minute. I've drawn another a wheel here that takes that 27-inch wheel, multiply that by our gear ratio of 3.53, and effectively has given us a wheel the equivalent of an 8-foot wheel in diameter, which has a circumference of 25 feet. Now in that gear configuration, one pedal turn does not push the bike at 7 feet like it did in the absence of gears. In this gear configuration, this bike now moves forward at a distance of 25 feet. And at a vigorous cadence of 90 RPM, we are now moving along at 25 miles an hour. And that explains why we want the bigger gears on the flats and on the slightly downhill, but a much lower gear going uphill, because the lower the gear, the less we're asking of our legs to push the bike forward with each pedal turn, but in the bigger gear, we're expecting more distance going forward with each pedal turn. This is Matt Gorman. I hope this has been helpful, and I'll see you next time.